Hey everyone, and welcome back. Ready for another deep dive?
Always.
Awesome. Today we're looking at some really cool research on using AI to predict, get this, landslides.
Sounds interesting.
Right. Now you might be wondering, how does AI even fit in with landslides?
Yeah, I'm curious too.
Well, it all starts with something that you might not expect. Soil depth.
Okay.
Yeah. And we have a paper here from June 2024 all about it.
Very recent.
Super recent. So landslides, they're obviously a huge threat, especially in places with mountains, right?
Yeah, absolutely. And knowing where and when they might happen, that's crucial.
For sure, for safety, but also just planning, like where to build stuff.
Exactly. Roads, buildings, anything really.
Okay, so how does soil depth play into all of this? When I picture a landslide, I'm thinking like a whole side of a mountain coming down.
It's a big deal. But the depth of the soil, it's really important for how stable a slope is.
Really?
Think of it like this. Deeper soil, it's like a really strong anchor holding everything together.
Okay, yeah, I see.
But if you have shallow soil, much more vulnerable. Heavy rain, erosion, all those things that make landslides more likely.
So deeper soil equals safer slopes.
Exactly.
Gotcha. But how do you even go about measuring soil depth all over a mountain? Seems pretty tough.
It is. The traditional methods, it's a lot of manual work.
What, like people out there with like shovels and stuff?
Well, more like drills. You have to actually drill into the ground at tons of different spots.
Wow.
It takes forever. And in rugged terrain, it can be really tough, even dangerous.
So that's where the AI comes in.
Exactly. AI has the potential to change the game completely.
Okay, let's talk AI. I'm picturing like a robot climbing up a cliff with a tape measure or something.
Haha. Not quite.
Yeah.
It's all about using information that we can collect much more easily. Things about the shape of the land,
Like,
elevation, the slope, the curvature, even how close an area is to water.
so all those features can tell us something about how deep the soil is.
That's the idea.
So instead of sending out a whole team with drills, we just feed this data into an AI and it tells us how deep the soil is.
You got it. Much more efficient, right?
Way more efficient. So what kind of AI are we even talking about here?
So this research used two main methods. Quantile regression forest, that's QRF, and then deep neural network, or DNN.
Those sound pretty intense.
They are powerful techniques.
But maybe a little too technical for, us non-AI experts. Can you break it down a bit?
Sure. So think of QRF like a really, really advanced decision tree.
Okay.
It looks at tons of data, learns how those topographic features we talked about relate to actual soil depth measurements,
And then?
and then it can make predictions for new locations where we haven't actually measured.
Got it. And DNN.
DNN is even more complex, lots of layers. It kind of mimics how our brains work,
Wow.
processing information in a super sophisticated way.
So both of them are learning from real data to make predictions?
Precisely. And the cool thing is, they didn't just test this in a lab.
No.
They went out into the field.
There too.
A real mountain, Mount Hwangyen, in South Korea, actually. It's known for having a lot of landslides.
Wow. So they really put it to the test.
Absolutely. They collected a ton of data, measured soil depth at, get this, 148 different locations.
Wow.
Yeah, they even looked at hiking trails and road cuts, anything to get a complete picture.
Super thorough.
They had to be. So then they had all this data, right? And they combined it with the topographic information.
Okay. And then?
Then the AI training begins. They feed all that data into the QRF and the DNN models and basically teach it to recognize what different soil depths look like based on the landscape.
So the AI is learning from the experts.
That's a great way to put it.
Cool. But before they could set the AI loose on the whole mountain, they had to do something called variable selection. What is that?
So you remember all those features? Elevation, slope, curvature, all that?
Yeah.
Well, they're not all equally important.
Oh, interesting.
In fact, using too many can make the AI less accurate.
Less is more.
Exactly. So they needed to figure out which ones mattered the most for predicting soil depth.
How do they do that?
They used an algorithm called the Baruta algorithm. It helps identify the strongest relationships between those features and the soil depth.
So the algorithm figures out what really matters.
And it picked out some key features like relative relief, the difference between the highest and lowest points in an area,
Okay.
slope gradient, how steep it is, and the TWI, which tells us how wet an area is likely to be.
Interesting.
Yeah, and some other things too, like profile curvature and indexes related to erosion and sediment movement. So we've got our AI all dressed up in its most relevant features, trained on real data from a real mountain.
The big question is, did it work? How well did they actually predict the soil depth?
That's what we'll find out. Stay tuned to see if this AI lived up to the hype.
Okay, so the AI is all trained up and ready to go. What happened next? How did they test it out?
Well, the big question was, could it actually predict soil depth accurately? Remember they had all those real-world measurements from Mount Hanyan?
Yeah,
So they compared the AI's predictions to those measurements
makes sense.
to see how close they were.
How to do?
Both models did pretty well, actually. Both the QRF and the DNN were able to predict soil depth with a good degree of accuracy.
Okay, but how do you even measure that? Like, what's considered accurate when you're talking about soil depth?
Good question. It's not just a simple right or wrong.
Right.
They used a few different metrics. One was root mean squared error, RMSE for short.
RMSE, okay.
Basically, the lower the RMSE, the better. It means the AI's predictions were closer to the real measurements.
Got it. So low RMSE equals happy scientists?
Pretty much.
So what kind of numbers are we talking about here?
Well, for the QRF model, the RMSE was 0.198.
Okay.
And for the DNN, even better, 0.166.
Those sound pretty small, but I don't really have a sense of what that means in terms of like actual soil depth.
Sure. Imagine you're trying to guess how tall someone is, right?
Okay.
An RMSE of 0.166 would be like being off by less than 2 inches on average.
Oh, wow. That's pretty good.
It is. So the AI was definitely hitting the mark when it came to soil depth.
Impressive. But we're not just interested in soil depth for the sake of it, right?
Yeah.
We want to predict landslides.
Exactly. So the next step was to take those soil depth predictions from the AI
Okay.
and use them to calculate something called the factor of safety, or FS.
Factor of safety. What is that?
Basically, it tells you how stable a slope is.
Oh, okay.
Higher FS means it's more likely to stay put. Lower FS means, higher risk of a landslide.
So the lower the FS, the more worried we should be.
You got it.
So how did they actually test this whole factor of safety thing out?
They looked at a real event, a major rainfall that happened back in July 2012.
Oh, wow. A real world example.
Yeah, 260 millimeters of rain hit Mount Huangyan, which is a lot. That kind of rain often triggers landslides.
So they used data from that event and combined it with the AI's soil depth predictions.
Exactly. To see if they could have predicted what actually happened back then.
What happened?
The results were pretty amazing, actually. The model that used the DNN predictions, it was spot on.
Really?
Yep. It correctly identified the areas that experienced landslides during that rainfall with an accuracy of, get this, 86.9%.
86.9%. That's incredible. This AI is like a landslide psychic.
It's pretty remarkable. The model that used the QRF predictions did well too, but the DNN was definitely the star.
So the DNN was consistently better.
Yeah, in this case, it achieved higher accuracy, both for soil depth and for the landslide prediction.
Wow. So how did they measure the accuracy of the landslide predictions specifically? It can't be as simple as just looking at a map and saying, yep, the AI got it right.
Nope, it's more complicated than that. They used something called an ROC curve.
An ROC curve?
It's a way to visualize how well the model distinguishes between true positives, the actual landslides,
Okay.
and false positives, areas it flagged as risky, but that didn't actually fail.
Right.
And they calculated the AUC, that's area under the curve. Basically, higher AUC means a better model.
So like a better score on a test.
Exactly. And the model with the DNN soil depth predictions, it had a very high AUC, which just confirmed how well it could predict those landslides.
So big success for the AI. But there's got to be more to it than just the numbers, right? What are the implications of all this?
That's the really interesting part. Think about it. If we can predict landslides this accurately, it could change everything. It could. It has huge implications.
Yeah, like what?
Well, we've been talking about landslides, right? But this could be applied to so many other natural hazards, too.
Like?
Floods, earthquakes, even volcanic eruptions, you name it.
Wow. So this kind of AI could totally change how we prepare for all kinds of disasters.
I think so.
Yeah.
Imagine we could pinpoint the areas that are most at risk for all these different threats.
And then?
We could use that information to make better decisions. Where to build, how to design early warning systems, all of that.
It'd be like having a heads up before anything bad happens.
Right. But even with the best AI, predicting these things, it's not perfect.
Yeah, nature's pretty unpredictable.
Exactly. There are just so many factors that come into play.
So we can't, like, completely eliminate the risk.
No, but we can get a lot better at managing it.
Right, by using this kind of technology.
And by doing more research. The more data we have, the better the models will get.
It's amazing to think how fast this field is moving. What do you think the next few years will look like? For this technology, I mean.
That's a good question. I think we're going to see AI being used more and more for predicting natural hazards, for sure. And that could lead to some really positive changes,
Like,
like saving lives, making our infrastructure safer, even improving things like insurance and risk assessment.
that's pretty incredible. We started with the AI predicting soil depth, and now we're talking about the future of disaster preparedness.
It's all connected.
That's what I love about science. You never know where it's going to take you. Well, this has been an amazing deep dive. Thank you for all the insights.
My pleasure. It was fun.
And for our listeners, we'll leave you with one final thought to ponder. As AI keeps getting more advanced, what do you think it will mean for us? How will it shape how we interact with the natural world? This has been the deep dive. Until next time, keep exploring, keep questioning, and keep diving deeper.